about to do some testing with multi-AZ. If I go and look at my SQL Server, RDS SQL Standard, you can see there that that's configuration should be multi-AZ, which should be down here somewhere. I've just done it, so there you go, multi-AZ. So that's all set up. I've got connectivity to it. Everything's all good. I'll just go back to, so I've got TST6 here, which is our primary SMS server. This one's the secondary. Both are up, both are active. This server here, SQL API status, so TST6 is the current active server as far as the SQL API interface is concerned. Both have checked in with UTC time, so all looks healthy there. In terms of the operations logs, it's just a couple of health things this morning. Otherwise, it's all clear. And the system's operational. So what we're about to do is we're about to see how these VMs respond when I do a reboot of RDS. So a reboot of RDS simulates a multi-AZ failover. It actually does failover from one SQL server to another. So let's go and do that. I'll select my databases. This is it here. Do an action, and I'm going to do a reboot. This probably might take, I don't know, a minute. Let's just see what happens. Reboot with failover. Yes. Confirm. Okay, so it's rebooting. Okay, so it's now available. So let's go and have a look at, let's start off with TST6 first. Let's do find logs, see if we've got any issues there. Links. Informational. Okay, so let's go down the bottom. Let's have a look here. So 1647. Health service had pushed a message off. Message flows has resumed. Okay, well, that's good. Did it actually detect anything? And did it reconnect? So these are the questions we've got to ask ourselves. All right, let's look at the attendant log. Last updated 2 minutes ago, so it's updated something. Okay, so it said at 14:56, it said unable to connect to database. So that's pretty much when we started it. Saying it's, you know, availability group. It's good. Let's just expand that. Let's just have a quick look here. So this is just simply saying how I can't connect. So it enters what's called a phase 2 timer set for 3 minutes. So we should see that update very soon. Just go and check a few of the other logs. Let's look at the receive log. Okay, so it had a connection and it doesn't appear to have logged anything as such. TX master. Okay, so it's not logged anything as such. Let's look at these TX services, so that these TX services are all sub-processes or separate binds. So this one here at 5 o'clock, it's now 5 o'clock, it's just written something to the log. So it obviously detected issues. It set up a phased error. Went into the same sleep timer as the other one, 3 minutes. And it says, yep, I'm going to attempt to reconnect to the database, which it's done. And it's logged the fact that it's recorded and recovered, from a critical event on the SMS platform on TST6. Looks like it's got a TX SMPP socket abrupt disconnection, which sort of makes sense. So we should see that will reconnect eventually. Yes, it's now reconnected to Cinch, so that's worked perfectly. And my guess is that all the other sub-processes, these are all binds, these are binds. So TX1, that's bind 1. So he would have done the same thing as well. Bind 1 is typically reserved for high priority. And he reconnected and actually sent out an SMS, a health check SMS, which is scheduled, which is perfect. So that's good. Let's go back to the attendant. See if he's updated his status, because he went into a 3-minute timer recovery. So phase 1, phase 2, and it's recovered from that. And it's detected that some of the services had stopped earlier. So they would have stopped by design. Then the attendant has restarted them. Let's just go and look at the status of the services, make sure they've all restarted correctly, which they have. Everything's running. Excellent. Let's look at the API status, make sure 6 is still the master, which he is, and they're both checking in. So this is UTC time. And yeah, so this is the update frequency. Every minute, these servers check in. The decision time in terms of who takes over control, we allow 5 minutes, so basically a 2-minute for a reboot across multi-AZ, and a bit of a 3-minute additional bugger factor there, so that, yeah, there's plenty of time for these sort of events to occur. Okay, the DB status, everything's all good there. That's normal. Let's check the operations logs. Okay, so these are all the additional entries now that each of these services have written. And they were all socket connection, reconnection type things, so that's all good. And you can search for the services that you want by using this, type in and put a filter in there and say contains, so you can just select out whichever log entries you're interested in. Right, let's look at 7. Let's first of all make sure all the services are running, which they are. And let's go and look at some of the logs on this server. Programs logs. Let's look at the attendant log on 7. So, yep. So he's correctly logged the fact that, yep, this was the issue here when we did the reboot. Phase 1 went into all of its processing, reconnected the database, because that was that 2 minutes between, I believe, 1656 and 1659. And then it said, yeah, I've recovered from that critical phase 2 event, and I'm restarting some of the services that decided they would stop, which is by design. That's excellent. Good. Let's go look at some of the other logs here. So the TX log, again, this is like what would be a normal priority bind 5. Yep, and he's reconnected to Cinch, which is perfect. And establish reconnection to the database. Check out delivery status. So these sub-processes here, these take all the delivery receipts and update them. As you can see, quite a bit of work going on during the day with QA. And it basically said, yeah, I'm detected the error, very similar log entries to the previous ones and on 6 as well. And then at the end of the day, it's recovered from a critical event, which is the failover of RDS. So this would be one of the very few applications out there in AWS land, which has been written and designed for AWS RDS failover, making sure that it reconnects and traps the errors and logs them and establishes connectivity back to the system. I'm just going to go and check. I've got this is an Outlook Web Access. So in our installer user, this is actually the admin. So you can see here that each of these SMS gateways send alerts when connectivity fails to the SMSC for SMPP connections. Provides health check information as well, which can be configured to either an admin or a operational team. But this one here is what I'm after. So you can see here that at 4:56 was when I did the failover, the reboot of RDS. It detected the critical one, dropped an email off to the admin team saying, hey, I'm in a phase 1 event here. This is what phase 1 means. We're waiting for 10 seconds. And then ultimately, if it goes into a phase 2, which it did, then it's going to wait for 3 minutes, which it did. And then it reattempted to connect to the database, which it did. If it went beyond that, that would be a serious SQL RDS type problem. And it would then go into a full cycle resolve and so on. The cool thing here is that it gives you all of the information about the connectivity, what the statement was it was trying to do, this type of stuff. And this is not just for one service, this is for all of them. So it's really smart in the way that it encapsulates and sets up semaphores within the stack so that each of the services know exactly what's going on. And it saves a lot of replication and duplication of messages. So you can see you just get these sort of reports. So I didn't see one for TST6. I got phase 1, phase 2 for TST7. Not TST6, so I'll double look at that. All good. All right, well, I will do some additional testing and just make sure that everything continues to operate successfully after a serious SQL RDS failover to another zone, simulating a zone failure. All good.